Good morning, boys and girls. I'm Miss Spector Kane, and I'm going to be teaching you a 6th grade math lesson today on volume. Last week, we discovered how to find the surface area of a rectangular prism. That's the outside of a box or a rectangular prism. This week, volume, we're going to talk about the inside of the box. Our essential questions today are, how do I find the volume of a rectangular prism by counting unit cubes? This is a unit cube. That's what we're using today for unit cubes. And how do I find the volume of a rectangular prism using a formula? So those are the two things we're going to investigate today. Our objective is to find the volume of a right rectangular prism with fractional edge lengths by packing it with unit cubes of the appropriate unit fraction edge lengths, and show that the volume is the same as would be found by multiplying the edge lengths of the prism. So what is volume? The amount of space that a substance or object occupies. Okay, in human terms, that means how much stuff can we fit into this box? How much space is available inside the box? When people are making boxes for objects, like, for instance, the sweet and salty cashew bars, they have to decide what size box they're going to make, so how many ever they're going to put in here will fit. Just like your 2-liter soda bottles, they have to know how much soda it will hold before they will make it so that all of the soda will fit inside. It's how much the inside will hold. Today, we're not going to deal with soda bottles, which would be cylinder shaped. We're going to deal with just rectangular prisms and how much they will hold on the inside. In what units do we measure volume? Now, when we discussed area, we know that it's measured in square units. Square units, the reason it's called square units is because you're saying length times width. Okay, so that's two things you're multiplying together. That's where the square unit comes from. So you might have meters squared because you're measuring two things, length times width. But in volume, you're adding an extra thing into volume. You are measuring length times width times height. So therefore, you have meters squared because you're having to measure 3 different things. So these are called cubic units now. They're no longer square units, they are cubic units. A 3 will come after your measurement instead of a 2 when you're dealing with volume. This is an example. You have length, width, and height. So therefore, length, width, and height, 3 different things, so you're going to have to multiply them together. Okay, this is a rectangular prism. I want us to talk for a minute about the pieces of a rectangular prism. Okay, the first thing, does the rectangular prism have any edges? Let's talk about an edge. Just as if you were on a cliff, you would have a cliff's edge. Where would the edge be? That's right, right here. These are edges. That's an edge. I'm just going to label it E. That's an edge. That's an edge. That's an edge. 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 think I did one too many here. Hang on. That goes all the way across. 1, 2, 3, 4, 5. There's not 7. I messed up somewhere. Edge. Because that would be 4 for that. 1, 2, 3, 4 for that one. That's an edge, and then this is an edge. So with a rectangular prism, you have one, because you have your bottom layer, you have your top layer, you have your side piece, you have your other side piece, and then you have top, bottom, side, side, and then front, front. Which actually, if you did a net, let me draw it as a net, that would be much better. You would have this piece, not an artist, I'm sorry. Okay, it would look like that. And you would just simply count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16. Wait, let's just do this. Sorry. We all make mistakes. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, but then this one would be 19 because they're sharing, 20 because they're sharing, 21 because they're sharing, 22, 23, 24. So it has 24 edges to it. And you basically can just say 8 times, I'm so messing up on this. It's going to be 4 times 6 is 24. Okay, sorry about that. I made that confusing. Okay, and then does it have any corners? Yes, it has corners. What's another name for corners? Another name for corners is the vertice. A vertice is another name for a corner. Okay, and how many flat surfaces? The flat surfaces, another name we learned last week for a flat surface is a face. And we know that it has 6 flat faces. 6 flat faces that make up a rectangular prism. Okay. How can we count all of the what's a way that we could find the volume of a rectangular prism? There's a real easy way that we can do that if we're using cubes. Okay, so let's take a look at this. If I have this, it's a flat cube piece, and I can find the area with this. It's not hard to do. I can simply count the cubes, correct? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The area of this is 12 units squared because it's flat. It's just the area. But now we are going to make this is actually cubed because it is still one layer and it's a cube. So now we are going to make another layer using the same exact amount. Okay, so now we've built a box, okay? And it's still 4 for the length, 3 for the width, but now what have we added? We've added height. So now we can still do the same thing. We can still count all the cubes and we can get an answer. Okay, so there's 12 on the bottom, there's 12 on the top, 12 plus 12. We get 24 units cubed. Okay, just keep that in the back of your head for a minute. Okay, same thing here. We have 9 units cubed, but we want to make additional layers to this. It would be the same process. These are not wanting to stick. So let's say that I made the whole thing, okay? And it's 3 units by 3 units, but it's also 3 units going up. And the whole thing was filled. You know the bottom layer was 9, so we could say 9 plus 9 plus 9, and that is what, boys and girls? 27. So we have 27 units cubed. And it would be the same thing with this one. We could say if we have 2 units, you started with 6 on the bottom, and let's say we put one more row of these, we would have 6, and then plus 6 more would give us 12 units cubed. Okay, so far we have the measurements by counting cubes. But the thing is, cubes are not always going to be with us. Okay, let's take a look. There are other ways we can find the volume besides just counting all the cubes. I want you to take a look at the one we built, the 3 by 4 by 2. What is another way that you think we can possibly find the volume of this figure without having to count every single cube? Because if we wanted to fill a fish tank up with water, like a big fish tank up with water, we would have to put a lot of cubes into that fish tank in order to know how much to fill the tank up. So there has to be a way. Well, we know it has something to do with the length, and we know it has something to do with the width, and we know it has something to do with the height, because I've been saying those words a lot today. So can anybody think of what that could be? The formula for finding the volume of a rectangular prism is length times the width times the height. Let's go back to this one. We had 24. How many do we have across for the length? 1, 2, 3, 4. So let's put a 4 up here for the length. And let's put a multiplication symbol. How many do we have for the width? 1, 2, 3. So let's put a 3 here. And how tall is it? The height is always how tall it is. 1, 2. So 4 times 3 is 12, and then you do that times 2, and you get 24 units cubed. Okay, now let's take the one that's going to make a square. We have 3 going across for the length. We have 3 going back for the width. And then we have 3 going up for the height. So 3 times 3 is 9, times 3 is 27 units cubed. Now, this is the one that is 2 for the length, 3 for the width, and 2 for the height. So we have 2 for the length times 3 for the width times 2 for the height. 2 times 3 is 6 times 2 is 12 units cubed. So you get the same exact thing when you use the length times width times height, instead of having to count every single cube or put models together. Let's try this with a real problem now. If you have pencil and paper, please try this at home, because your problems that your teacher is going to give you are going to be a lot like this. So, our length, what is our length? Our length is 10 centimeters. So we're going to write 10 times. Then we're going to find our width. Our width is 5 centimeters. And then what is our height? How tall is it? It's 6 centimeters. I would suggest, as the numbers get larger, that you do 2 at a time. You multiply 2 at a time and then bring the third one in. So we have 10 times 5 is 50. And then 50 times 6 is 300, and I believe it was centimeters. Always remember to label your items, centimeters cubed. So the answer to this problem would be 300 centimeters cubed. Okay, let's look at another one. I made them a little bit more difficult as we went along. So this one is 20 centimeters for the length, 8 centimeters for the width, and 16 centimeters for the height. So we've got 20 times 8 times 16. So the first thing you're going to do is 20 times 8 is 160. And then you're going to multiply 160 by 16. So you can come over here and do your math. And however you multiply, that's your choice. And you get 2,560 centimeters cubed. So that would be the answer, 2,560 centimeters cubed. Length times width times height. Okay? Now this one has a decimal in it. So let's try one with a decimal. The length is 13.5. That's the length. The width, it's a little sketchy on this one, but it's this one, 5 centimeters. And if you get them confused, we really want you to know the length, the width, and the height. But on this one, the reason I'm saying 5 centimeters is because it's the shorter of the two. But they're both kind of sitting where the height is. I know the 5 centimeters because this is a shorter line, okay? So the height is 18.5 centimeters. Okay, so I'm going to start off with 13.5 times 5. And remember, when we do our decimals, we have one number in the tenths place after the decimal, none here, so it's going to be 67.5. So then we're going to multiply 67.5 by 18.5. So you have 25, carry the 2, 35, 36, 37, and then you get 33, and then that would be 50, and then 48, 49, 53, and then you have to go over a third place for the place value. Now, when you're placing your decimal here, you have 1 decimal here, and you have 1 decimal here. So you're going to have to move the decimal 2 times, which means you've got to go to the hundredths place, which is right here. And this one is also in centimeters. So the answer is 1,238 and 75 hundredths centimeters cubed. Okay, they can also, volume is real life. You're very seldom, except for in school, going to be given a problem and just told to find the volume. Volume is real life. Volume is where you're going to actually have to find the volume of something in your real life world in order to solve the problem. So I've put a word problem on the board. Bingo's doghouse has the dimensions of 5 feet by 3 feet by 4 feet. Sasha's doghouse has the dimensions of 4 feet by 4 feet by 5 feet. What is the volume of each doghouse? In other words, how much can each doghouse hold? Okay, so first, the question is first we've got to find out what is the volume of each doghouse. So for Bingo's, and we're going to label it B, it's 5 times 3 times 4. So we're going to say 5 times 3 is 15, and then times 4, and that's going to equal 60 feet squared, cubed, sorry. And then Sasha's doghouse has the dimensions of 4 by 4 by 5. So 4 times 4 is 16, and then you're going to multiply that by 5, and you get 80 feet cubed. Now, how many were thinking that because which one did you think was bigger to begin with? Okay, that's right, because the 4 is bigger than the 3 there, and both the other numbers are the same. So the first question's answered. We found the volume. The second question, whose doghouse is larger? Well, Sasha's is larger. Sasha's is larger. And then it says, how much larger? So we need to take 80 feet cubed minus 60 feet cubed, and you get 20 feet cubed. So Sasha's doghouse is 20 feet cubed larger than Bingo's. Next week, we will be discussing statistical questioning. It sounds like a big word, and it sounds like it's really going to be difficult, but it's not. It's actually a lot of fun where we're going to do some survey questions, and I am going to survey my students to get their results about some ice cream, and we're going to find out some statistical data, and then we're going to plot their points on what their data is. So tune in next week. Have a great week.